Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart with you as always. I've got a Fender Blues Deluxe reissue in the shop today, and it has an interesting problem in that on certain notes you can hear a low-level grumbling in the background, but it's quiet otherwise, and it isn't on every note. So let me see if I can demonstrate it to you. You're going to have sharp ears to hear it, but let's hope we can demonstrate it for you. Right, so I've got the guitar here and I'm finding it's on this B note. I can't hear it there. Can you hear that? Bit like a rattly echo. I'll just do it once more, so don't listen to the note, listen behind it. Can't hear it there either. I hope you can hear that kind of echoey rattle in the background. Now, I've had this before on amps, and the fact that it's note specific almost always indicates to me some kind of resonance, some mechanical resonance. For example, the valve vibrating or some other component vibrating. My first port of call here is a preamp valve, microphonic. So what I'm going to do is change the preamp valve sequentially, V1, V2, V3, and see if we can get rid of that just by changing a preamp valve. It's pretty solid there now, so we should be good to change something. Just do it once more. Don't know if you can hear that kind of sort of sound in just underneath the note. Right, so let's change, well, the first thing we will do is to tap the preamp valve to see if one is obviously microphonic, and take it from there. Okay, using a Mark I chopstick we can just tap the valves. Nothing there. Nothing there. And nothing obvious there. You'd hear a real ting 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 ting, particularly on these early valves, if they were microphonic. Power valves are a little bit microphonic, so it could be the power valves. Right, let me show you a little trick for diagnosing this. Yes, these power valves are a little bit microphonic. I put my money on those actually. So anyway, a little trick is get yourself a tea towel, a double or triple thickness, and what we're going to do is grab the valves via the tea towel. This obviously stops you getting too hot. So let's prove the problem's still there. Definitely. That was horrible. And I'm just going to grab this valve here. Still as bad. Try this one. That is quite horrible, that. Let me try the preamp valves. What we're doing with a tea towel, of course, is dampening out any. That's a horrible noise. That's interesting. That's really quite a nasty rattle, that. Let's just have a little tap around the board. definitely a resonance there. Sort of, I can hear that actually making kind of vibration resonance when I, yeah, it's quite sensitive actually. What's interesting, it seems less sensitive on the valve board than it does on here. This could be a very nasty fault actually. No matter where I tap, I can hear it. And unfortunately it doesn't change as I go along the board. Well, I think I've probably got to just put a new set of valves in just to eliminate that. But I think it's something on this board. Ooh, yeah, it's very sensitive, this board. Nasty. That is a nasty problem. Okay, this is fairly tedious and slow, but what I'm doing is swapping the valves one by one. So I put a new valve into V1 and still got the problem there. So now I'm going to put the original valve back in and put a new valve into V2 and proceed like this. I don't expect this to cure it, but I've got to do it. It would be crazy of me not to try the valves first. I can hear that grumbling away slightly now actually without a signal going through it. It can be very hard to find this kind of problem. You won't be able to hear it, but I can hear there's something going on this board when I tap it. This is going to be a so and so. Right. Yeah, there's definitely something happening with this board. I can hear a very low level hum which comes and goes as I touch it. It's gone now. Now it's back. Right, let me just take this V1 out and see if okay, the problem's still there, so it's not in the V1 section. So we can sort of gradually eliminate sections, find out whether it's in the preamp section or the power amp section, that sort of thing. Just put that back. Now I'll take V2 out. Put a new V2 in. As I say, I don't expect it to be this, but we have to do this. We'd look right chumps if we spent hours diagnosing this only to find out it was a valve. It's grumbling away there when I took that out of standby. There's that hum. Still got the problem. Hopefully you can hear that in the background. So it's not V2. Actually I'm going to take V2 out as well. and see if I can, yeah, I can hear it grumbling away. So I don't think it's in the V2 section either. You won't be able to hear that, it's very faint. Yes, so it's after V2. Put that back in. Take out V3. Put a new V3 in. Terrible. Awful. Flexing the board to see if there are dry joints underneath it. Yeah, pressing that does stop the resonance. Ah, that's interesting. There's a board screw missing out there. I don't think that will do it, but we will certainly put one in there just to make sure. Pretty sure that won't be it. Right, so it's not V1, V2 or V3. So let's put the original V3 back in. Right, that's that. And now we will turn off and put a new pair of power valves in. Right, we've got a new pair of power valves in. I'm not hopeful of this doing anything. Actually, I can hear it grumbling away a little bit, but that might be a different problem. Well, that's interesting. That might have cured it. Yes, I can't hear that at all now. Okay, well, let's put the original valves back in. The reason I'm surprised is because tapping around the valve board didn't cause as much grumbling as tapping around the main board. But you know what it's like, these resonances can go through all kinds of which ways and you never quite know what's going on. I'll tell you what's happening in a moment if I do confirm that it's these valves. Well, whilst we're waiting for it to warm up, what's happening is the speaker, of course, is vibrating these valves and shaking the elements in them. And if the elements are not very stiff and at exactly the right frequency, they'll vibrate in sympathetic vibration at their resonant frequency, and you'll hear that as some kind of horrible grumbling underneath the note. Yeah, I can hear that. Yes. I can feel these valves vibrating as I touch them. Yes, that confirms it. I can actually hear that resonance coming and going as I grab that valve. Yep, that's cured it. I'm surprised the T-towel didn't do it. It's this valve here. Actually, oh no. Yeah, it's that valve there. Good, well that's excellent news. Because that means we just have to put a new pair of valves in and bias it obviously, and we're good to go. That's somewhat surprising, that. And I'm very pleased about that, because that could be quite nasty if it's some sort of dry joint underneath this board. It's very hard to find that kind of thing. So, by the way, I put a new board screw in there and it wasn't that. Right, well let's get the new valves in and biased it up. By the way, if you're watching this video and you've got a similar problem, go for the valves first obviously, but it can also, I've known it to be a dry joint on for example these capacitors, but that's normally a much worse sound. You get a kind of ding sort of sound when it's a dry joint on a capacitor vibrating. For obvious reasons, you're opening and closing a high voltage contact. So if you've got a horrible, nasty crackling sound on certain notes, I would go for a dry joint on typically the smoothing caps, but maybe somewhere else. But this is a very subtle, low-level resonance. That's much more likely to be valves rattling around. Good. Okay, the amp's on, and as you can see we've got 423 plate volts and 35 milliamps. That's actually not too far off. I'll do the actual calculation, but that's close enough actually, I think. But let me do the calculation just to make sure. I suspect that's a little low, the bias current. So 424 plate voltage, 34 milliamps. Let's see what it should be. Okay, the correct bias should be about 47 milliamps, so it's a little bit under that. So I'm just going to adjust the bias, and to adjust it you use this little thing here. I'm just going to adjust that whilst watching this. As you can see, it's coming up. I'll do about 45, that's fine. 46 milliamps, absolutely fine. Those 6R6s might be okay in another amplifier. It's just they're right next to the speaker there, and they're just resonating. What are we doing? We're doing this, aren't we? Pretty sure that's okay. Yeah, that's fine. That's perfectly alright, that. Now, just to finish up on this amp, whilst you're looking at this amp, always check the electrolytic caps here. These have been done and they're okay. They've got decent F&T caps in there. Yeah, so they've got new caps in, but the other problem is these resistors here, they get very hot, and there are a couple of Xena diodes here as well. This is the plus and minus 15 volt supply for the op amps. But I can tell from this that these are good. Normally you see a lot of burning around these boards, a lot of burning around the Xenas. They all look good to me, so I don't think we need to worry about that. But that is an area to watch on these amps. So if you're looking at your amp, check the electrolytics, see if there's any leakage, and check to make sure it's not all horribly burned around this area here. If it is, you're going to have to pull the board out and redo the joints. But this one's looking good, and I think we can call it a wrap. So I'm going to say I won't do a formal sign off. Thanks very much for watching. I hope you enjoyed this one and learnt a little bit about these resonances that can happen. Funny little underlying notes under the notes that you're playing. Almost always some kind of mechanical resonance caused by the speaker vibrating the components. Go for the valves first of all, otherwise go for the caps. Right, well thanks for watching. I'll catch you on the next video.